What you are looking at is a fully functional, enterprise-grade assessment operations dashboard built entirely in Microsoft Excel. This is not a template. Every single formula, every data rule, every visual you see here, I built from scratch. In this video, I am going to walk you through the entire project, the data design decisions behind it, the formula I used, the automated logic, and finally how it all connects into this dashboard. My name is Adil, and this project is called the National EmSAT Deployment Framework, a mock simulation of how a Ministry of Education testing analyst would actually manage a large-scale national exam rollout across multiple school networks. Let's get into it. Before we dive into the sheets, let me give you the big picture because understanding why I built this the way I did is just as important as the how. The core idea of this project is to simulate what an MOE assessment analyst or a data professional in a national testing body would actually need to manage. Number one, student level performance data. Which students are performing at which level, across which emirates, schools, subjects, and curricula. Number two, school level operational readiness. Before an exam rolls out, someone needs to know, is the school's infrastructure ready? Are they fully staffed? Are there any compliance risks that need to be flagged and actioned? These are two completely different dimensions of the same problem, and that's exactly why I built two separate datasheets and then connected them through a single interactive dashboard. So the architecture of this project is three sheets: assessment data, operational readiness, executive KPI dashboard where everything comes together to leadership. Let's start with the data. This is sheet 1, renamed to assessment data. It contains 200 rows of mock student records. I am going to walk you through each column and explain exactly why I choose it. Column A is the student ID. Now I could have just typed numbers, but that's not how a real government database works. I used this formula. Let me break that down. The prefix DXP 2026 immediately tells you the region, Dubai, and the academic year. The text row part auto-generates a zero padded number, so instead of just 1, you get numbers like 001, 002, etc. That's important for sorting and for visual consistency in reports. And because I used row -1, the formula is completely dynamic. I dragged it from A2 all the way to A201 and it generated all 200 unique IDs instantly, no manual typing, no risk of errors. Column B is the Emirate, Dubai, Abu Dhabi, Sharjah and Ajman. I choose these four because they represent a realistic distribution for a UAE-based national assessment, including multiple emirates, makes the data meaningful for regional comparison, which you will see become very important in the dashboard later. Column C is school type, public or private. This distinction matters a lot in education analytics. Public and private schools often follow different curricula, have different resource levels, and may show different performance patterns. Including this lets an analyst slice the data in a very operationally relevant way. Column D is curriculum, MOE, CBSE, and IGCSE. This is a very specific choice. The UAE has a genuinely diverse school curriculum landscape. MOE is the Ministry of Education National Curriculum. CBSE is the Indian curriculum. highly prevalent because of the large South Asian expat community. IGCSE is the British curriculum common in international schools. Any real assessment analyst working in this space would need to account for curriculum type when interpreting scores. A student's raw score might mean very different things depending on their curriculum background. Column E is subject, which will contain mathematics, science, and English. These are the three core assessment areas in most standardized testing frameworks, so this was a natural choice. Column F is the raw score, exam scores ranging from 40 to 100. Now notice the visual treatment on this column. I applied conditional formatting with data bars. Every cell has a proportional bar inside it, so you can instantly see performance without reading individual numbers. This is not just cosmetic. A testing analyst reviewing 200 rows of data benefits enormously from this kind of at a glance visual. High score jumps out, clusters of low scores immediately signal a problem area. Column G is where the real logic lives, the proficiency level, and this is driven by a formula I want to highlight specifically. The ifs function is Excel's multi-condition evaluator. It works through each condition in order and returns the first match. So if raw score is 85 or above, the student is advanced. If it's 65 or above but below 85, they are proficient. If it's below 65, they are emerging. These thresholds aren't random, they are modeled on how real standardized assessment bodies classify performance bands. You will see similar structures in PISA, EmSAT, and national competency frameworks. And I have applied conditional formatting with highlight cell rules on top of this column. Emerging is highlighted in red, immediate visual flag for intervention. Proficient is in yellow, meets standard but room to grow. Advance is in green, exceeds expectations. Now when a school administrator or analyst looks at this sheet, they don't have to read every cell. The color language tells the story instantly. Column H is the assessment cycle, either term 1 baseline or mid-year review. This is a very deliberate project management element. National assessments don't happen once. They run in cycles, and tracking which cycle a score belongs to is critical for measuring growth, comparing cohorts, and reporting to leadership. Column I is the school ID, and this one has a clever trick behind it. The formula I used was rand between generates a random number between 1 and 10 representing 10 different school networks. But here is the crucial step, and this is something a lot of beginners miss. Rand between is a volatile function. That means it calculates every single time you make any change to the spreadsheet. Your school IDs would keep randomly shuffling every time you typed anything. To log them in permanently, I copied the entire column and pasted as values. This replaces the formula with its last calculated result, a static number. The school IDs are now fixed, consistent, and ready to be used as a reliable lookup key. Finally, the entire dataset is formatted as an Excel table. This gives us structured reference, automatic filter arrows, alternating row formatting for readability, and most importantly, it means any formulas that reference this table will automatically expand when new rows are added. That's good data engineering practice. You don't hard code ranges, you use dynamic structures. Now let's move to sheet 2, which is operational readiness. This sheet is where I shift from data analyst to project manager. This sheet tracks the operational health of all 10 school networks involved in the assessment rollout. Let me walk you through each column. Column A is school ID. This is the linking key between this sheet and the assessment data sheet. It's what allows us to do the VLOOKUP you are about to see. Column B is digital infrastructure status. The values are ready, which means no issues, risk hardware check required, which means a technical flag, and pending audit, which means compliance check in progress. I applied conditional formatting on this column. Pending audit is highlighted in yellow, not red, because it's not a crisis. It's a warning, something that needs attention before rollout, but it's manageable. In a real school readiness assessment, this column would feed directly into a deployment decision. You would not roll out a national exam to a school flagged as pending audit without resolving it first. Column C tracks whether each school is fully staffed or understaffed. Again, this is a pure operational project management. Exam invigilation requires a minimum supervisor to student ratio. If a school is understaffed, that is logistical risk that needs to be escalated and actioned before exam day. Column D is the compliance risk level, low, medium or high. I applied conditional formatting here too. High risk is highlighted in red. This is the most critical signal in the entire operational sheet. If a school is high risk, something has to happen before exam day. It's not optional. Column E is the action required field, and this is where the operational playbook lives. I highlighted no action required in green using conditional formatting. Green means cleared. In a large scale rollout dashboard, a coordinator needs to see at a glance which schools are cleared and which ones are flagged. Column F is the curriculum field, and this is populated dynamically using a VLOOKUP with a choose trick that I am particularly proud of. Here is the formula. Let me explain what's happening here. Standard VLOOKUP can only look to the right. It searches a column and returns a value from a column to its right. But in my assessment data sheet, the school ID column is to the right of the curriculum column. Normally, that would break a VLOOKUP. The choose trick is a workaround. It creates a virtual two-column array on the fly, placing school ID as column 1 and curriculum as column 2, allowing the VLOOKUP to work correctly even though the data is in the wrong order. This is an advanced Excel technique. It demonstrates knowledge beyond basic lookups, and in a real operational environment, you don't always get to reorganize source data to suit your formula. You need to work with what you have. This is the playoff. Everything we just built, all 200 rows of student data, all 10 school risk profiles, all the formulas and conditional logic, it all flows into this single executive dashboard. Let me walk you through what's here and why each component was designed the way it was. Before we get to the charts, notice the visual step. The background is a very light gray, not white. This is intentional. A white background with white chart areas blends everything together. The light gray background makes your chart areas and KPI cards visually pop, like cards on a surface, which is exactly how enterprise dashboards are designed. The title reads National EmSAT and Standardized Assessment Deployment Framework, and the subtitle is MOE Standardized Assessment Section, Regional Operations and Performance Analytics. This framing matters. A dashboard without a clear title and context is just charts floating in space. Labeling it like a real ministry document immediately elevates the professional impression. Chart 1 is the academic proficiency distribution by emirate. This is built from a pivot table connected to the assessment data sheet. It shows for each emirate how many students landed in each proficiency tier: advanced, proficient, or emerging. Notice the legend is perfectly clean, just three labels. I cleaned this up deliberately because Excel's default pivot chart legends are notoriously messy. The moment you have both a count metric and an average metric in the same chart, Excel combines them into long, ugly labels. My solution was to separate the metrics into two distinct charts rather than forcing everything into one. That keeps the legend readable and the story clear. Chart 2 is state performance benchmarks. This is built from a duplicate pivot table, a twin of the first, but this one focuses purely on the average raw score per emirate. The reason I split these is simple. Student counts and average scores are two completely different units of measurement. Forcing them onto the same chart axis creates a visual conflict where the numbers don't scale meaningfully against each other. By separating them, each chart tells a single clean story. Bar chart works perfectly here because it shows variations across emirates, allowing leadership to instantly see if one region is consistently underperforming. Chart 3 is the Regional Infrastructure and Examination Compliance Risk Profile, and this one comes from the operational readiness sheet, not the student data. This donut chart shows the distribution of schools by compliance risk level, how many are low risk, medium risk, and high risk. This is the project management lens of the dashboard. While the first two charts speak to academic performance, this chart speaks to operational readiness. A leadership team reviewing this dashboard gets both dimensions simultaneously: performance and delivery risk. Now, this is the part that makes the dashboard truly interactive. These two boxes on the left are slicers, one for curriculum and one for subject. Watch what happens when I click CBSE. Both charts, the proficiency distribution and the performance benchmarks, update simultaneously. That's because I connected both pivot tables to the same slicers through report connections feature. This means a curriculum coordinator can filter the entire dashboard to CBSE students, instantly see how they are performing across all emirates and whether the schools serving them are operationally ready. The dashboard becomes a real analytical tool, not just a static picture. This is the difference between a spreadsheet and a dashboard. One last detail you will notice: the dashboard looks perfectly clean with no raw tables cluttering the view. That's because I hid the pivot table rows using Excel's row grouping feature. The underlying tables are still there, the charts are still connected and fully functional, but from a presentation standpoint, the dashboard surface is clean and professional. When you are representing this in a job interview or in a meeting, you don't want a hiring manager or a director seeing raw pivot data underneath your charts. You want them focus on the insights. If you found this useful, drop a like and consider subscribing. I will be sharing more portfolio projects like this one, and if you are working on a similar project or applying for a similar role, feel free to drop a comment. I am happy to talk through the design decisions. Thanks for watching.